All right, good morning, everybody. So if you're following along in the notebooks, we should be on, well, if you follow the order of the notebooks, we should be on the strings notebook. But I'm actually going to jump ahead to arithmetic because arithmetic is very easy to do in Bash, and it's going to be useful. I'll introduce a couple of constructs in the arithmetic notebook that you can use for the next assignment, which is also out now. So the next assignment, the assignment 2 was posted earlier this morning. All right, so arithmetic. Let me hide this. Can I do? No. All right. All right. So Bash supports arithmetic, but it only gives you integer arithmetic. So you can't do any floating point stuff in Bash, which you wouldn't normally want to do anyway from the command line. So exactly what kind of floating point, exactly what type of integer arithmetic you get depends on your version of Bash that you're running. If you're running a 64-bit version of Bash, you probably get 64-bit arithmetic. I'm not actually sure how to check how many bits ints are actually represented on in Bash. Probably a way to do it. I don't know how to do it. The arithmetic operators are basically the same set of operators that you get in most programming languages, so addition, subtraction, multiplication. If you do division, it's integer division, so it's truncating division. It's the same as in Java, right? So you compute the quotient, throw away the everything after the decimal point. Bash has exponentiation, so it uses star star, which is the same as Python, I believe. So star star is your exponentiation operator. Again, it's all integer. It's integer exponentiation in this case as well. All right, so if you want to do arithmetic in Bash, it's pretty easy to remember how to do it. You just put everything inside double round brackets. So that construct right there evaluates an expression as though it were an arithmetic expression. So remember, Bash thinks everything's a string. Right, so if inside the double round brackets, so if you didn't use the double round brackets, Bash would not know whether you wanted arithmetic or some sort of string operation. So by putting stuff inside double round brackets, you tell Bash that this is an arithmetic operation. Now, one of the nice things about this is that as soon as you use the double round brackets, Bash assumes everything is arithmetic. So if you try to access a variable inside double round brackets, you don't need the dollar operator anymore. Right? So in other words, you can just use the name of the variable because Bash is not going to think that you're using a string. It's going to think that you want to access the value of the variable to perform arithmetic on that value. Right? So there is an example of a simple arithmetic expression. Right? So double round brackets, inside I have x equals 1 plus 2. The other nice thing about the double round brackets is the spacing inside the double round brackets doesn't matter anymore. Bash is going to try to interpret whatever is in there as some sort of arithmetic expression, so the spaces are insignificant now. So this makes a variable x and assigns the value of x 3. Well, assigns the value of 3 to x. So if you run that, you get 3. Right? No big surprise there. So no dollar sign is needed to get the value of a variable inside double round brackets. Right? Everything's arithmetic, so it doesn't make sense to multiply two strings, x and y, for example, here. So here we have x is 1, y is 5. Right? Notice that if you're doing a plain assignment, you don't have to put that inside double round brackets. Right? So if you want to assign the value 1 to x, you can just write x equals 1. It doesn't have to be inside double round brackets. The 1 is still a string. Right? It's not actually the number 1. It's still a string. As soon as the value gets used inside double round brackets, Bash interprets the value of the string as though it were a number. Right? So here you're going to get 5 in this case, right? 1 times 5. And of course, if you change the values, you get the expected result. Right? Okay, so what happens if you use a variable name, but you haven't set the value of that variable yet? Right? Or what happens if you use a variable but that variable is actually a string of some kind. It's not really a number. Right, so here's an example where x is the string ABC. Right? Y is the string 5. Right? And then on the next line, I'm going to use the double round brackets to compute some sort of arithmetic expression. Right? So here I'm going to try to add x and y. Bash does something funny here, right? It tries to interpret the x as though it were a numeric value. So ABC is not a numeric value. So it simply replaces the value of ABC with 0. It doesn't change the value of x, right? It simply uses 0 instead of ABC, which is confusing. It also doesn't tell you that there is something funny happening here, right? So you don't get a warning, right? It just says, well, x is 0, and then adds 0 and y, which is 5, and you get 5, right? So we get 5 there. Here, x is the empty string, right? Y is 5. Again, if you try to write x plus y inside inside double round parentheses, or double parentheses, the empty string gets replaced with a 0, and you get 5 again, right there. Right. I haven't shown you unset yet. So if you have a variable in your bash environment, so here we have x. If you write unset x, that effectively removes x from the, it removes x as a variable, right? Or sets x to, unsets x, right? So it removes x as a variable. There's y is 5. And now if I use x again, right? X has been unset, right? So it doesn't have a value. Bash substitutes the value 0. So you get 0 divided by 5, which is, of course, 0. Right? And notice all of this happens without any warning or without any error message. Right? Bash just automatically substitutes in the value 0 for you. So you have to be a little bit careful when you're doing arithmetic. So that double parentheses is actually a command in bash. So double round brackets, some arithmetic expression inside the double round brackets is a command. Right? Every command in bash has an exit status. Right? So that means the double round brackets has an exit status, which is weird, but that's the way it works. Right? So if the stuff inside the double round brackets is equal to 0, right, then the exit status is set to 1, right? Which you can interpret as true. Which you would normally interpret as false in bash. Right? So if the expression is not equal to 0, then the exit status gets set to 0, right? So remember, normal exit status is 0, right? So the exit status of a command that doesn't encounter an error is normally 0. Right? The exit status of a command that encounters an error is normally non-zero. Okay, so here we've got something that evaluates to 0. The exit status gets set to non-zero value. Right? So here it gets set, gets set to 1, I believe, yes, right? So once again, if the value inside the double round brackets is 0, the exit status of the double round brackets is 1, right? Anything else, the exit status is 0, right? Like that. Which is weird, but that's the way it works. All right, so bash uses exit statuses as conditions, right? And so if you write an if statement or a loop, right, so the loop will be controlled by some sort of condition, right? It'll run as long as some condition is true. If statements will execute as long as the condition is true. You can use the double round brackets as a condition, right? So here, we're checking. So remember what dollar number is, right? Dollar number or number is the number of command line arguments passed to a script, right? So here I'm testing, is the number of command line arguments passed to the script not equal to 1, right? And if it is, then apparently this script outputs an error message, right? So here's a script that requires at least 1 command line argument. Sorry, exactly 1 in this case, right? If the number of command line arguments is not exactly 1, then we print an error message. Right, so there's the use of echo, right, to print a string to standard output. Now remember, error messages should go to standard error. So I haven't shown you how to redirect standard output to standard error. Right? We know how to redirect output to a file. We don't know how to redirect one stream to another stream. And so the way you do that is with this funny syntax here. Right? And so what this does is it redirects. There's actually a 1 in front of here, but you don't need the 1 because this is standard output. Right? So greater than and 2 means take the output of standard output, redirect it to error stream number 2, which is standard error. So that message gets printed to standard error. which is what you should normally do if you're outputting an error message or a warning message, right? Those should normally go to standard error. Right? If you leave this off, it goes to standard output. Right? The exit command stops a script immediately after the command, and it sets the exit status to whatever number that is there. Right? So when you set the exit status of a command, it should be 0 if the command succeeded successfully. It should be positive and not 0 if the command encountered something unusual, right? So if there's an error or something odd has happened. I believe the only valid exit statuses are from 0 to 255. And I believe the ones above 128 are reserved for something. Anyway, your exit status here should be 0 or positive, right? If it's an error, it should be positive. And so there's an example of testing the number of command line arguments that are passed to a script. If you need at least 3 command line arguments, right, you can check, are the number of command line arguments, right? Is it less than 3, right? And if it is, error message, right? Again, using greater than &2 to redirect standard output to standard error, and then exit with a non-zero positive status here. And here's another little script that uses an arithmetic condition to set the exit status. So this one tests whether or not the value passed to the script is even or odd. Well, it tests if it's even. So if it's even, it sets the exit status of the script to 0. Right? And if it's odd, it sets the exit status of the script to 1. All right, so first of all, we're going to check, is the number of arguments to the script not 0? Right? So is there at least one argument passed to the script? Right? If there are no arguments passed to the script, right, then this script simply assumes that the value is even. Right? And so it sets the exit status to 0. So if there's at least one, we're going to look at the first command line argument. So that's stored in special parameter 1. Right? Then I'm going to divide val by 2 and look at the remainder. Right? So there's your remainder operator in Bash, right? Exactly the same as in Java. Right? So divide val by 2, look at the remainder. If the remainder is not 0, I know it's odd. Right? If it's odd, the script sets the exit status to 1. Right? In all other cases, so if it's even or if there's no command line arguments, the script simply ends. And when a script simply ends, it sets the exit status to 0. Right? So there's no explicit exit 0 at the end here. You can put it in if you want to. It's fine if you do or if you don't. Right? So call the script with an even number. The exit status gets set to 0. Right? So remember, the exit status of the most recent command is stored in question mark. Right? So print out the value of question mark by writing $question mark. Right? So it's 0. If you pass in an odd value, you get 1. Right? And if you pass in no value, you get 0. Right? Negative numbers work as well. Right? So that's fine there. Right? And of course, if you use a non-numeric value, what do you get? Right? So if I use a non-numeric value, remember how this works. Right? Val becomes ABC. And now inside the double round brackets, because ABC is not a number, that gets replaced with 0. Right? So if you pass in a non-numeric string, you're going to get 0 as well. So it thinks ABC is even. Right? If you wanted to, you could write a little bit more sophisticated input checking. Right? You can try to test whether or not this number is actually an integer. But before we do that, we have to talk about something else. So I'll show you how to do that probably in a few lectures. All right, a little bit more arithmetic. So here's a simple random number generator. Now on your assignment, you're going to get you're asked to generate random numbers in a completely different way. So the way I'm showing you here, don't do this on the assignment. The assignment's very explicit. It says use only blah blah and blah. Right? But for the notebook purposes, I'm going to show you how to generate a random number in a not very good way. Right? So this is if you need something that's cryptographically secure, right? You don't want to do it this way. The random number generator that's built into Bash is not a particularly good one. But it's useful if you just need to generate some sort of random value for some reason. Right. So Bash has this variable called all caps random. It's a bit of a funny variable. So every time you ask for the value of random, it changes. When you write $random somewhere, internally your shell is generating a random number and storing it inside that variable. So every time you reference random, it expands to some random number between 0 and 32,767. Right. You can even assign a value to random if you want to. That changes what's called the random number generator seed. That's not important for the purposes of this course. You can actually unset random as well, which you probably shouldn't do. If you unset random, then random doesn't become random anymore. So you probably don't want to do that. All right, so here we're going to, I want to generate so normally you don't want to generate a random number between 0 and that. Right? You would like to generate a random number between some minimum and some maximum value. So how do you do that? Well, let's take a look how you do that. Okay, so we're going to write a script. If there's no command line arguments given to the script, basically we're going to return the value of random. Right? We're going to give back a random value between 0 and 32,000. Right? If you give one command line argument, then our script will interpret the command line argument as some value n, and you're going to get back a random value between 0 and n minus 1. Right? And finally, there's a bug in this notebook. Between m, there's a missing ampersand. Star, sorry, right there. Oh, and I still didn't fix it, sorry. That's not what I meant to write. There's a missing, how do I do this again? There, that's what I want. Right? Yes, there it is. Okay. If you give it two command line arguments, then it assumes the two command line arguments are two integer values, m and n, and you get a value between m and n minus 1. Right? So for example, you could generate a random number between 10 and 15 if you wanted to by passing in 10 and 16. Okay, so this script requires at least, if you give it more than two values, we're going to say that that's an error of some kind. Although you don't have to do it this way. You could just simply ignore the command line arguments past 2. Right? But here we're going to check. So if the number of command line arguments is greater than 2, then we're going to output an error message. Right? We're going to say, hey, I don't know what to do with the extra command line arguments. Right? And now, basically, we're going to have a little if statement that checks whether or not we have 0, 1, or 2 command line arguments. And so, I guess I should explain what an if statement looks like in Bash. I didn't really do that. All right. So a Bash if statement starts with the keyword if. Right? There's a condition here. So here we're using the exit status of the double round brackets as our condition. I always write it like this. So I always write it with a semicolon and then on the same line. But there is another way to write this, which I'll show you in just a second. Right. The then, if you write it this way, the semicolon is required. Right. Whoops, sorry. Then there's the keyword then, and the if statement ends with the keyword fi, fi. Right. So if spelt backwards. Else if is just elif, so same as Python. And of course, you can have an else part of the if statement as well. Okay, so if we have 0 command line arguments, we're going to return. We're just going to return the value of random, right? And so, we're going to print out the value of random. So here we just echo the value of random. Right? Now, if you have a value, if you give it one command line argument, then we want a value between 0 and the command line argument minus 1. And so to get a random number between those two values, you take the value of random, right, and then you just compute the remainder after dividing by n, right, the command line value, the command line argument. Right, and so that always gives you back a value between 0 and n to minus 1. Right, $1 is just n in this case. Right? Sorry, I guess I shouldn't have called it n because I'm using the variable n here. So $1 is the maximum value minus 1. It's the maximum value plus 1. Right? And so you can just output that value there. Right? Finally, if you want a random value between m and n, right? And so what you can do is you can generate you compute the width of the range, right? So n minus m, which is right there, right? Compute the remainder after dividing by the width of the range, right? So that gives you back a random value between 0 and the width minus 1, right? And then add back in the minimum value of the range, right? So add back in this case, the first command line argument. Right? And so that produces a random value between m and n minus 1, right? Where m would be $1 and n would be $2. Again, I probably shouldn't say n because there's my variable n there. Anyway, right? And I claim that that script there will generate a random value between m and n. Okay, so no command line arguments. Right? You're going to get back some value between 0 and 32,767, right? And it's different every time you run the script. Right? This one should produce a random value between 0 and 9. Right? So remember 10 minus 1 is 5, 8. I'm going to try to get the 9 or the 0. There's the 0, so that's good. And this should generate a random number between 30 and 40 minus 1, so 30 and 39. And so there's 36. And of course, again, as you run this, it gives you back a random value every time. Right? So arithmetic in bash is really not a big deal. Just put everything inside double round brackets and away you go. Right? If you want to check a numeric condition, the easiest way to do it is to use the double round brackets. Right? So for a numeric comparison of some kind, if you put it inside double round brackets, you can just write it like you would in most other programming languages. There's another construct. So there's the double square brackets that you can also use. If you want a numeric comparison in there, it looks really weird. But we'll talk about that when we talk about conditional statements a little bit later on. Right? And so I think so what I've shown you today gets you through, and in the previous lectures, gets you through, I think, the first 3 or 4 questions of the assignment. There's 5 questions. The last part of the assignment, if you want to do it today or sometime, you should read the conditional statements notebook, and that'll tell you how to finish off question number 5. You might need it for a part of question 4 as well, right? But for now, I'm just going to go back and talk about strings. Right? Any questions about arithmetic? It's pretty easy in bash, right? Just throw it inside double round brackets and away you go. Okay, so I'm going to jump back to strings. The strings notebook is here because it's actually an extension of the variables notebook. So when you're working with strings, remember, bash thinks everything's a string. So if you have something stored in a variable and you want to get its value, right, we call that parameter substitution. Right? Everything's a string, so it's not surprising to learn that when you do a parameter substitution, you can also perform some sort of string manipulation as well. Right? So you can do things like get the length of the string that's stored in the variable. You can extract a substring from a string that's stored in a variable, and so on and so on and so on. Right? There's a lot of variations of parameter substitution. So this notebook doesn't cover them all. If you click on that link, you can get the basic documentation for all of the string substitutions. You probably are still going to need to do some research, i.e. Googling, to figure out exactly how to use those, to use the expansions that are described in the notebook. Right? The documentation doesn't give you a lot of examples. All right, so we've got a string stored in a variable somewhere. And I would like to know how many characters are in this string. Right? So to get the length of a string, the syntax is funny. Right? So in Python, you're used to writing length, len, everywhere, right? And that's nice, right? So these modern programming languages have nice ways to access the length or the size of a collection of some kind. Right? Python is particularly nice. It's the same function for any kind of sequence. Right? When you're working with these older languages, that's not the case. Right? So you know in Java, to get the length of the array, it's .length. Right? To get the size of a list, it's .size. Right? To get the length of a string, it's .length double round brackets because it's a method. So bash is similar in that respect. Right? To get the length of a string, you have to write something funny. Right? So here's my string, sys220. It doesn't have to be double quoted here, but it is. right? If you want the length of the string, you're going to write something that looks like that, right? So you're actually going to perform a parameter substitution. So $, right? In this particular case, you need the braces. Right? So the braces have to be here, right? So remember, if I just wrote $str, right? That's the value of the string stored in str, right? If you want to get the length of the thing stored in str, then you need the number sign in front of the variable name, right? So $, braces, number sign str will give you the length of the string. So that's 7 in this case, right? Syntax is weird, but once you get used to it, it's pretty straightforward. You're going to use a similar syntax to access the length of an array, right? The number of elements stored in an array. Okay, so there's the length of the string. Now, can you get a substring from a string? The answer is yes, right? Okay, so to get a substring from a string, right? Again, it's a parameter substitution. So it's going to look like $, brace, variable. So that's str in this case, right? And in this case, you want a colon followed by what's called the offset, right? So that expands to the substring of str, starting at index offset, where offset is a 0-based index, right? So the first character in str would be index 0, right? Second character in str would be index 1, and so on and so on and so forth, right? So by passing in that value there, you can get the part of the string starting at that index going to the end of the string. I should really split this up. There's too many things here. I'm just going to hang on. Give me a second here. Edit. I'm going to copy this cell, and I'm going to paste it above. And then I'm just going to start deleting stuff from it. This will be easier to read. Okay. So there's my string A through J. Right? S:0 means give me the entire string. Right? So there's A through J. S:1 means give me the string starting at index 1, so starting at the second character, going to the end of the string, right? So this is going to give you B through J, right? And of course, so on and so on and so on. So 3 will give you everything starting from the D, right, going to the end of the string. Right? Now, if you don't want everything going to the end of the string, you pass it in a second value, right? So second colon. And now it's the length. So this is slightly confusing if you remember Java's substring method. Right? So Java's substring method takes in an index for the second value here. Right? Python slice takes in a second value. Takes in an index for this. Bash uses the length of the substring instead. Right? So that's a little bit confusing. So here, so let's start at character 0, and I would like just the first character from the string. So that's going to be the substring of length 1. Right? So that's going to give you the A. Right? If you want the B, that's starting at index 1. Right? Again, I want the substring of length 1, so the second one. Right? And so on. Right? So that'll be the C, and that will be the D. Right? And so on and so on and so forth. So if you wanted to iterate over the characters of a string, right, you're going to replace that 3 with some loop variable instead. Right? So S:I:1, where I ranges from 0 to the length of the string minus 1. Right? And that will let you loop over the individual characters of the string. All right, so here's some more examples here. Right? So 3:5 will give you the substring starting at index 3, so the D, right? 5 characters long. So it should give you D, E, F, G, H, I believe. This is why I said why it's hard to read, right? So it's right there. Right? 3:4, starting at the D, 4 characters long, so D, E, F, G, right? This one's interesting, right? So you can ask for the substring of length 0, which gives you back the empty string. So it's printed out on that last line there, right? It's the empty string, so you don't see anything. right? So that's the character starting, the substring starting at index 1, 0 characters long. Offset can be negative, in which case it's treated as an offset from the end of the string. So this is similar to Python's negative indexing as well, right? So a negative offset is measured from the end of the string. Oh, you need the space, which is weird. It gets weirder. So here, if you want all the characters starting from the last character, right? So remember, that's your offset, so that's the index where you're starting at. -1 is the index of the last character in the string. That will give you the last character in the string. So this should give you the J, which is right there. Right? -2, index of the second last character in the string. Right? That'll give you the I and the J. -3, index of the third last character in the string. The space is important here. So if I do that and run it, you get something completely different. Right? The reason this happens is because :hyphen means something different in a parameter substitution. This is later in the notebook. Right? So here, Bash thinks you're doing the other kind of parameter substitution. Right? If you want a negative index, you need the space there. Right? Weird, but that's the way it works. Right? Right? So :hyphen means something else, and we'll get to that shortly. So the second argument, the length can also be negative. Right? So the length can be negative, in which case it's treated as an offset from the end of the string as well. Right? So the expansion yields the substring starting from index offset. Right, so starting from the first number, going up to but not including the index length. Right, so now Bash treats the second value as though it were an index, which is weird again, but that's the way it works. Right. Again, all of this is bordering on trivia for me. Right, so I'm not going to ask you a question like what does this give you? Right, this is all here for your information, but you're not going to be asked about this. Right. So if you're asked for some sort of indexing question, you just need to know what this number means and what a positive value for this number means. Right? So you don't have to remember all this negative business and all this space stuff for purposes of a test. Right? If you're writing Bash code, you need to know this. Well, you might need to know this. So that's why I'm telling it to you. All right. Weird thing number 2. If you're using the length, you don't need the space in front of the minus sign anymore, right? Which is strange, but that's the way it works, right? So back here, I needed the space because as far as Bash is concerned, variable name :minus means something special, and it's not indexing, right? It's not string sub. It's not getting a substring, right? So you need the space here to tell Bash that, hey, you really want a substring here. Right? As soon as you use the second colon, right, Bash knows you're trying to get a substring, so it doesn't care about the space now after the second colon. And I don't even know if it's an error to put the space in or not. But we can find out in a second. Right. So when you're using a negative sign, negative value for the length, it now becomes an index. So this is the string starting at index 0, going up to but not including the last character of the string. So that's going to give you A through I. Negative value for the length, so it now becomes an index. So this is starting at index 1, going up to but not including the second last character in the string. So that's B through H. Right. -5, so starting from the fifth last, going up to but not including the third last. So that's F and G here. Right. I guess we should try the space. I don't know what happens if it lets you do that. Oh, yeah, it works. Okay, so that's fine. That's good. Right. So after the second colon, you don't need the space. You can put it in if you want to, if the value is negative. All right, so that's how to get a substring. And for the most part, that's all that I'm going to ask you on a test. Right. The rest of this stuff you'll get asked about on an assignment, but I'm not going to make you memorize all this stuff. There's so many of these things to know, and it's very confusing what all of these things actually mean. Right. Every time I need to use one of these, I have to go look it up because I can't remember. I don't remember what they are. Right. All right. So you want to remove the front part of a string where the front part of the string matches some pattern that you can define, right? And so that's what this particular form of the parameter substitution is for, right? So there's your string, and then it's either a single number sign or a double number sign, depending on exactly what it is you want to do, right? And then you specify a pattern, which I'll show you how to do in just a second, right? And so all of this expands to the part of str formed by removing the shortest leading part of str that matches the pattern. If you use two number signs, then it's the same thing, except it removes the longest part of str that matches the pattern, right? And the part that's removed is from the front of the string, right? So one number sign, shortest part that matches the pattern at the front. Two number signs, the longest part that matches the pattern at the front of the string, right? Gets removed. Okay, so here's file.text. That's my string, right? And so this is a pretty common form for a file name, right? File name dot some extension, right? So here our extension is .txt, right? I would like to remove the .txt just to get the name file, right? For whatever reason. Maybe I want to rename file.text to something else, right? Okay, so I would like to remove all of that, right? Sorry. I got that all backwards. I already screwed it up. I want to get the extension, so I want to get the txt, right? I want to know that this is a txt file. So that means I would like to remove the file dot in this case, right? And so to remove the file dot, I can specify a pattern. Right? Now, to specify the pattern, it's basically the wildcards and this square brackets with the character set inside, right? So it's the same as file name expansion in this case. So here, star dot means, right? So remember what the star means when you're using it as a wildcard, right? Star means match any string, right? The dot doesn't have any special meaning, so it's just the dot. So that pattern there is anything followed by a dot, right? With the single pound sign, I'm going to remove the shortest part of the front of the string that is anything followed by a dot, right? So that's going to remove the file dot. Right? With two pound signs, it's going to remove the longest part of the front of the string that is anything followed by a dot, right? So in this particular case, they both give you the same result. I'm going to do the same thing here. I'm going to copy this cell, paste it back in, and I'm going to delete the second part here. All right, so in this particular case, you're just going to get txt. Right? Okay, so when will this make a difference? So this makes a difference when the pattern can be matched, when the front of the string matches the pattern in more than one way. Right? So remember what star dot means? It means anything followed by a dot. Right? So there's anything followed by a dot. Right? But there's also this, right? Anything followed by a dot. Right? So the first form, with a single pound sign, removes the shortest part that matches the pattern. So it removes file dot. Right? The second one is the longest part that matches the pattern. So it removes file dot text dot in this case. And so now you get, right? And so, right, that is the result of that. Right? And the last one, which is probably what you wanted, is the result of the second one there. Right? So if your file name happens to have multiple extensions in it, which is not super common in Windows or Mac, but might happen in, it happens quite a bit in Linux actually, you probably want the second form here. Right? All right, so inside a script, it's occasionally useful to get the name of the script itself. So the way that you call the script, remember, is stored in special parameter 0. Right? But the way that you call the script might include some path to get to the script. Right? If you just want the name of the script, you've got to remove the part leading up to the name of the script. Right? You need to remove the path leading up, the directory sequence leading up to the name of the script. Right? So the name of the script is what's called the base name. There's actually a command in Linux that'll give you the base name. So you don't have to do it this way. Right? If you want to play around with these parameter substitutions, though, you can use the double pound substitution to remove everything up to and including the final directory separator. Right? So right there, I'm calling the script called script name. Right? So if I look at what's stored in special parameter number 0, right, it's all of this. Right? It's how you called the script. So you get all of that. Right? If I want just the name of the script, so in other words, if I just want that, right, I need to strip off all of this. Right? So how do I strip off all of that? Right? I want to remove the longest part of the front of the string, that is anything followed by a slash. Right? So there's anything but a slash. Right? Double pound sign, remove the longest part at the front of the string that matches the pattern. Not surprisingly, you can do the same thing at the end of the string. Right? So if you want to remove the part of the string at the end of the string that matches some pattern, right, you use the % sign instead of the pound sign. Right? How anybody remembers it's % instead of pound, I don't know. Right? Generally, you have to look it up. Right? So it's the exact same thing. Right? With a % sign pattern, you're going to remove the shortest part at the end of the string that matches the pattern. Right? 2% signs followed by a pattern. Remove the longest part at the end of the string that matches the pattern. Right? Again, where the pattern is defined using star, question mark, and square brackets. Okay, so I'd like to remove the txt in this case, or the .txt. Right? So what's the pattern that matches .txt? Well, .star works. Right? If you happen to know it's .txt, you can write .txt. If you want to remove the extension and you don't know what the extension is, it would be .star. Right? You can remove the longest part that matches the pattern, right? And that's going to give you the exact same result in the first case. Right? So this is going to give you file and file. Right? In the second case, right, that's the shortest part that matches the pattern, so that's going to remove the .zip. Right? And in the second case, that's the longest part that matches the pattern at the end, so that's going to remove the .txt, .zip. So that after removing the shortest, you get file.txt, right? After removing the longest, you just get file. Okay, and finally, I think this is the last thing I'll do for today, and then we'll finish off the rest of this notebook on another day. Right? You can replace a substring inside a string. When you replace a substring, the replacement string can have a different number of characters than the original string. Right? Sorry, than the substring that you're replacing. Oh, bless you. Okay, so to replace a string, there's two forms, again, right? So single // followed by the pattern, followed by a second slash, followed by a replacement string, expands to str with the first occurrence of the pattern replaced by the replacement string. If you want to replace all of occurrences of a pattern, use the double //. Right? If you want to replace some number, but not necessarily all of them, there's no way to do it using a simple parameter substitution. Okay, so here is sparring with a purple porpoise. Right? And here's my replacement right there. Right? So that says replace the first P with a T. Right? So that's going to give you starring with a purple porpoise. Right there. Right. Right. Now, remember what the so the substitution doesn't change the original string itself. Right. So remember what all of these substitutions do. They perform the substitution and then replaces the substitution with the resulting string. Right. But it never changes the actual string itself. So if you print out S again, it's still the original string sparring with a purple porpoise. Right. If you'd like to replace all the P's with a T, use double // P, right? And now you get starring with a turtle tortoise, right? All the P's are replaced with T's, right? And again, the original string is not changed, right? The replacement string does not need to be the same length as the original. So here you can use question, right? right? And so here the first P gets replaced with 3 question marks. Notice the question mark does not retain its special meaning, right? So it's not being used as a pattern here, right, as a wildcard match, right? It's the literal question mark. And so you can replace the first P with a series of question marks, right? Or you can replace the all P's with, say, 3 capital T's if you like, right? And that works as well. Right? And so there's substring replacement in Bash. All right, so I think we'll stop there. There are some more conversions in the notebook, and there are actually many, many more that you can read about if you're interested by following that link there. Right? I think you can sort of understand why I don't cover them all. Right? It gets very tedious to talk about all of them. All right, so we're done for today. I'll see you again tomorrow afternoon.